The night sky may seem serene, but the universe is a vast, chaotic abyss, far more terrifying than we dare to imagine. It is ruthless, unpredictable, and filled with objects that would rip you apart if you get too close. But we cannot stay home forever. Our curiosity about the unknown drives us to leave Earth and explore the cosmos. At first, this journey seemed harmless. We started with our neighboring planets. We found Mars. We found Venus. We stepped on the Moon, thinking that these celestial bodies were just cold, barren landscapes. But as we studied them further, we realized their dangers. We found Venus with its crushing atmosphere of sulfuric acid and temperatures hot enough to melt lead, and Mars with its dust storms that could envelop the entire planet. We found these planets were anything but friendly. Then in the 20th century, we moved beyond our planetary neighbors. We discovered asteroids. We discovered comets. We learned that a single collision with one of these could end life as we know it, just like it did with the dinosaurs millions of years ago. But we still kept pushing further. We still kept going far and far away into the cosmos, into the darkest of its secrets. Then we found black holes, regions of space so dense that nothing, not even light, can escape. But we did not stop, even if we were scared. Our technology improved, and our curiosity grew bolder. We left the Milky Way and entered into the vast emptiness of space. That's when we realized just how terrifying the universe really is. And that's when it hit us: our home in the Milky Way, our Earth, was actually the safe space. Out beyond our galaxy, the universe only gets more ruthless, filled with things, terrifying things, far beyond our understanding. The deeper we go, the more terrifying it becomes. And today, we are taking you with us. Brace yourself, because we are about to explore the most dangerous and horrifying objects in our universe. Our first stop is deadly celestial bodies. Deadly celestial bodies. Simply put, these are all the physical stuff in space, like planets, stars, asteroids, comets, and even black holes. Some are harmless, like the Moon or asteroids in a distant belt. But some are out for destruction. They are true cosmic killers. One of the deadliest kinds of these objects out there are Wolf-Rayet stars. Wolf-Rayet stars are supermassive, super hot, and extremely dangerous. They are not like our Sun, or even most of the stars you would typically find out there. Wolf-Rayet stars are in a class of their own. So, what makes them so dangerous? You see, Wolf-Rayet stars are in the last stages of their stellar evolution right now. It means they have used up most of their nuclear fuel. They have shed their outer layers and have now exposed their hot, dense core. And the terrifying thing is that they are not just shedding their outer layers gently. They are blasting them away in powerful stellar winds that travel at thousands of kilometers per second. These winds can strip off huge amounts of material, mass equal to the Sun, every 100,000 years, flinging it out into space. That means these stars are losing mass rapidly, creating these massive, chaotic clouds of gas and dust. Around them we call nebulae. These are often seen in beautiful, colorful images of space, but make no mistake, standing near one of these stars would be anything but pretty. Those stellar winds could rip apart anything that got too close. The terrifying thing is that Wolf-Rayet stars are ticking time bombs. All that mass loss and instability means they are heading towards an explosive end, which is a supernova. When a Wolf-Rayet star runs out of fuel completely, it does not just fizzle out. It explodes in one of the most powerful events in the universe. The explosion can briefly outshine entire galaxies, and shoot out deadly gamma-ray bursts. How can some rays be deadly? Wait for a few more moments, as we are going to explain it to you. For now, all you need to know is that if a gamma-ray burst from a Wolf-Rayet star hit Earth, let's just say it would not be pretty for any life on this planet. The radiation would fry the atmosphere, and the effects would be catastrophic. Luckily, the closest known Wolf-Rayet star is about 7,500 light-years away, so we are safe for now. But in cosmic terms, that's still pretty close. Now, scientists have been studying these stars for a long time, but there is still a lot we don't know. One of the big questions is how exactly these stars explode. Wolf-Rayet stars lose so much mass that they should technically run out of fuel more slowly. But they seem to go out with a bang faster than expected. Some theories suggest that the strong winds these stars produce are driving the instability. It speeds up their demise. Others speculate that magnetic fields could play a role, which twist and shape the stellar winds in ways that trigger an early explosion. Another fascinating idea is the potential link between Wolf-Rayet stars and black holes. When these stars explode, they don't leave behind a remnant like a neutron star. In many cases, they may collapse directly into black holes. You can imagine how deadly these stars are from the fact that they are so massive that even their explosive death leaves behind one of the most terrifying objects in existence, a black hole. So, how were these stars first discovered? Back in 1867, French astronomers Charles Wolf and Georges Rayet were studying the spectrum of light from stars when they found something unusual. Instead of the typical absorption lines in the light of most stars, they found emission lines. This was evidence that these stars were shedding material into space. That was the birth of our understanding of Wolf-Rayet stars, but it took decades of further study to find out just how deadly these stars really are. How many did we actually find out? You see, while Wolf-Rayet stars are rare in our galaxy, the ones we have discovered are just a fraction of what's out there. The universe is huge, and there are likely thousands more waiting to be found, each a ticking time bomb in its own right. And one more thing. If you are looking for Wolf-Rayet stars in our galaxy, you will want to focus on the constellation Cygnus. That's where you will find WR136, which is one of the more famous Wolf-Rayet stars, located in the Crescent Nebula. It is a stunning sight, but remember, this beauty is lethal. Now, if you thought Wolf-Rayet stars were intense, brace yourself, because we are now flying into even more extreme territory. When stars like Wolf-Rayet stars explode in a supernova, what's left behind can be one of the most dense and horrifying objects in the universe, a neutron star. And if that neutron star starts spinning incredibly fast, well, that's when we get a pulsar. Let's make it simpler by looking at some of these deadly objects. In general, pulsars are the leftover cores of massive stars that have gone supernova. But unlike regular neutron stars, pulsars have a unique trait. You see, pulsars are rapidly spinning neutron stars that send out regular pulses of radiation. These pulses occur because a pulsar has incredibly strong magnetic fields, and as it rotates, those magnetic fields generate beams of electromagnetic radiation, like X-rays and radio waves. These beams shoot out from the magnetic poles of the star, and when one of them points toward Earth, we detect it as a pulse. That's why pulsars get their name. They pulse with regular signals. Most pulsars spin between a few times per second and a few hundred times per second. The speed of their rotation depends on their history, including how they formed, and whether they are part of a binary system. But not all neutron stars become pulsars. To become a pulsar, the star has to be spinning rapidly and have a strong magnetic field. These conditions allow it to emit the beams of radiation that make pulsars so unique. Now this is the fastest known pulsar in the entire universe. When we say fast, we are not talking about a quick spin like a toy top. This pulsar is spinning 716 times per second. It is mind-boggling, and there is nothing else quite like it. This pulsar is what we call a millisecond pulsar. Why do we call it that? Because of its extreme speed. While most pulsars rotate a few times per second, this pulsar spins at a ridiculous 716 times per second. That makes it the fastest known spinning pulsar in the universe. And then this particular pulsar has about 1.4 times the mass of the Sun, packed into a sphere that's only around 20 kilometers across. This means the mass of the Sun has been smashed into something the size of a small city. It is insane. Now this pulsar is located in a dense region of space called a globular cluster. Specifically, it is in a cluster known as 𝗠ście𝘀𝘁, which is about 18,000 light-years away from Earth in the constellation Sagittarius. Globular clusters are tightly packed groups of stars, which often contain hundreds of thousands or even millions of stars. These regions are great places to find old, evolved stars, and that's where neutron stars and pulsars come into the picture. So, how does a neutron star get spinning so insanely fast? It is all due to a process known as spin-up. This pulsar is not spinning fast just because it is a neutron star. No, it had some help from a companion star. This pulsar is part of a binary system, meaning it has a stellar partner that it interacts with. Over time, this pulsar has been stealing material from its companion star, a process which is called accretion. As the pulsar pulls in material from the companion, it spins faster and faster, eventually reaching the breakneck speed we see today. The accretion of material from the companion star is not a peaceful event. The pulsar's immense gravity rips apart its companion star's outer layers, funneling that material toward itself. This steady flow of gas and material causes the neutron star to increase its rotational speed dramatically, leading to the millisecond pulsar we know. Aside from its blistering speed, this pulsar is part of a small group of other pulsars that spin faster than 600 times per second. These millisecond pulsars are rare, making them incredibly fascinating to study. Scientists are eager to understand how they manage to maintain such high speeds without tearing themselves apart. The thing is, neutron stars are incredibly dense, which gives them the structural strength to spin that fast without breaking apart. However, the forces involved are still extreme. At the surface of this pulsar, the matter is being flung around at about 15% of the speed of light. It is almost incomprehensible. Another one of the most famous pulsars out there is the Crab pulsar. This pulsar is located in the Crab Nebula, which is a remnant of a supernova that was observed by Chinese astronomers. The explosion left behind the Crab Nebula, which is a beautiful glowing cloud of gas. And at the center of that nebula is the Crab pulsar. The Crab pulsar is about 6,500 light-years away from Earth in the constellation Taurus. It spins about 30 times per second, which makes it much slower than the pulsar we are talking about. But it is still incredibly fast. You can imagine it like a small city rotating 30 times every second. So, how does the Crab pulsar work? The Crab pulsar, like other pulsars, emits beams of radiation as it spins. These beams are the result of the star's intense magnetic field, which accelerates charged particles to nearly the speed of light. These particles produce radiation that we can detect across the electromagnetic spectrum, from radio waves to gamma rays. Because the Crab pulsar is so well studied, it is one of the best understood pulsars in the universe. Scientists have observed it in almost every type of radiation, and it has been used to study a wide variety of astrophysical phenomena, including the behavior of supernova remnants, the properties of neutron stars, and even the nature of space and time itself. One of the most interesting features of pulsars is something called a glitch. Every once in a while, a pulsar's spin rate will suddenly change. It usually speeds up slightly. This is thought to happen because the crust of the neutron star cracks under the immense stress of its rotation. When the crust cracks, the internal structure of the star shifts slightly, causing the pulsar to spin faster. These glitches give us insights into the internal structure of neutron stars. The Crab pulsar is known for having frequent glitches, which makes it a perfect laboratory for studying how neutron stars behave under extreme conditions. Every time a glitch occurs, astronomers learn a little bit more about the physics of these dense objects. But why do we even want to study these deadly celestial objects? Well, pulsars are not just interesting because they are weird. They are also incredibly useful for studying the universe. Because pulsars are so regular in their rotation, they can be used as cosmic clocks. Scientists use pulsars to study gravitational waves, test theories of general relativity, and even search for new planets. The regularity of pulsars' pulses makes them perfect for studying the most extreme environments in the universe. For example, when a pulsar is part of a binary system with another neutron star or a black hole, the gravitational interactions between the two objects can cause tiny changes in the timing of the pulses. By measuring these changes, scientists can learn more about the behavior of gravity in the presence of extremely massive objects. As we continue our virtual journey through the cosmos, we come across another terrifying object: stellar remnants. These are the leftovers of stars that have gone through dramatic deaths, leaving behind beautiful but ghostly remnants in their wake. One of the most famous haunting stellar remnants is the Helix Nebula. The Helix Nebula is a type of planetary nebula, which might sound like it has something to do with planets, but it really doesn't. The name comes from early astronomers who thought these nebulae looked like planets through their small telescopes. So, what's the reality? The story of the Helix Nebula begins billions of years ago, when a star similar to our Sun was happily burning hydrogen into helium in its core. Over time, the star began to run out of fuel, and when it did, it started to swell up into a red giant. In this phase, the star's outer layers expanded out into space. Eventually, the outer material became unstable and was pushed away, leaving behind the hot, dense core of the star. As the core shrinks, it becomes a white dwarf, a star remnant that is incredibly hot but no longer undergoing nuclear fusion. The ultraviolet radiation from the white dwarf lights up the previously ejected gas, causing it to glow brightly and form the nebula we see today. Often called the Eye of God because of its resemblance to a human eye, the Helix Nebula is what remains after a star, much like our Sun, has reached the end of its life. But don't be fooled by its beauty. This is a scene of cosmic death on a grand scale. The Helix Nebula is located about 700 light-years away in the constellation Aquarius, and it is about 2.5 light-years in diameter. That's huge, over 15 trillion miles across. Yet, because it is so far away, it appears relatively small in the night sky. The terrifying fact is that this nebula is still expanding, moving outward at about 40 kilometers per second. Over the next few tens of thousands of years, it will continue to spread out and fade away, eventually becoming invisible as the gas disperses into space. What makes it unique, though? The Helix Nebula stands out among planetary nebulae because of its distinct structure. When viewed through telescopes, it looks like a gigantic eye staring back at us from space. The central white dwarf glows intensely, while the surrounding shell of gas takes on a blue and red appearance, creating the eye effect. The gases in the nebula include hydrogen, oxygen, and nitrogen, and it is the interaction of these elements with the radiation from the white dwarf that creates the beautiful colors we see. One of the most interesting features of the Helix Nebula is its complex structure. When viewed up close through powerful telescopes, like the Hubble Space Telescope, the nebula is not just a smooth ring of gas, it is filled with complex details. For example, astronomers have identified what are called cometary knots in the nebula, which are dense clumps of gas and dust that look like little comets streaming away from the central star. These knots are much cooler and denser than the surrounding gas, and scientists believe they formed as the nebula expanded outward. This nebula has fascinated scientists for years because it lets us look back in the future. In about 5 billion years, the Sun will run out of hydrogen fuel and swell up into a red giant. It will expand outward, likely swallowing up Mercury and Venus, and possibly even Earth. Eventually, the Sun will lose its outer layers, creating a planetary nebula much like the Helix Nebula. The core of the Sun will shrink into a white dwarf, and the surrounding nebula will glow brightly for thousands of years before slowly fading away. So, in a sense, when we look at the Helix Nebula, we are looking at the future of our galaxy and possibly even our planet long after we are gone. Similar to the Helix Nebula is the Crab Nebula, which is as terrifying as the former. It is located in the constellation Taurus, about 6,500 light-years away from Earth. At first glance, it might look like a beautiful, colorful cloud of gas and dust. But the reality of what this nebula represents is far more terrifying. This cosmic object is the remnant of one of the most violent events in the universe, a supernova explosion. Let's rewind a bit. In the year 1054, ancient astronomers across the world, from China to the Middle East, recorded the appearance of a new bright star in the sky. It was so bright, in fact, that it was visible during the day for weeks and lingered in the night sky for nearly 2 years. What they were witnessing was the explosive death of a massive star. The explosion, known as a supernova, released an enormous amount of energy, briefly outshining entire galaxies. The Crab Nebula is what's left of that explosion. It is a gigantic cloud of gas and debris, expanding outward from the center at mind-blowing speeds. But this nebula is not a usual place. It is a deadly object. It is filled with intense radiation and violent forces that make it one of the most hostile environments imaginable. The core of the star that exploded didn't just disappear. What was left behind is a neutron star, a rapidly spinning, incredibly dense object that's only about 12 miles across, but has more mass than the Sun. This neutron star is known as the Crab Pulsar, and it is what makes the Crab Nebula so unique. The Crab Pulsar is a type of pulsar, meaning it emits regular pulses of radiation as it spins. This pulsar rotates at an astonishing rate of 30 times per second, and as it spins, it sends out beams of radiation that sweep across the cosmos. Every time one of those beams points toward Earth, we detect it as a pulse of radio waves, X-rays, and even gamma rays. Speaking of gamma rays, the Crab Nebula is a powerful source of these incredibly energetic rays. Gamma rays are the most energetic form of light, and they are produced in some of the most extreme environments in the universe. The Crab Nebula's pulsar is so powerful that it accelerates particles to nearly the speed of light, and when these particles interact with the magnetic field of the nebula, they create gamma rays. These gamma rays are so energetic that they can easily pass through most materials, including the human body, which is why they are dangerous. If we were anywhere near the Crab Nebula, the radiation would fry us instantly. The Crab Nebula is also expanding at an incredible rate. The material ejected from the supernova explosion is still traveling outward at about 1,500 kilometers per second. That's roughly 930 miles per second. Even though the explosion happened nearly 1,000 years ago, the nebula is still growing, and it will continue to expand for thousands of years to come. The nebula's glowing appearance comes from the interaction of the high-energy particles from the pulsar with the surrounding gas. These particles excite the gas, causing it to emit light in a wide range of wavelengths, from radio waves to visible light and X-rays. This is why the Crab Nebula looks so colorful in images. It is because it is emitting light across the entire electromagnetic spectrum. The beautiful colors we see in photographs are actually representations of different types of radiation being emitted from different regions of the nebula. But there is something particularly strange about the Crab Nebula. Despite its glowing, colorful beauty, it is essentially a graveyard. The gas and dust that make up the nebula are the remains of a once massive star that lived and died in a violent explosion. The pulsar at the center is the core of that dead star, spinning rapidly. It is a ghostly reminder of the power it once held. And while the nebula might look serene from our distant viewpoint, up close, it is anything but peaceful. The sheer amount of energy contained within the Crab Nebula is almost impossible to comprehend. The explosion that created it released more energy in a few seconds than our Sun will emit over its entire 10 billion-year lifetime. The neutron star left behind is one of the densest objects in the universe, with a gravitational pull so strong that even light cannot escape from regions near its surface. Similar to this nebula is Orion Nebula, which is just as deadly, but the terrifying thing is that it is closer to home. Located in the constellation Orion sits the Orion Nebula, also known as Messier 42 or M42. This nebula is about 1,344 light-years away from Earth, which means it is the closest region of massive star formation to our planet. This nebula is massive because it is roughly 24 light-years across, and it is home to thousands of stars in various stages of their life cycles. Now, the Orion Nebula is a type of emission nebula, which means it glows due to ionized gas. The gas is primarily hydrogen, and it is being excited by the intense ultraviolet radiation coming from hot young stars embedded within the nebula. As the hydrogen atoms absorb this energy, they become ionized, and when they recombine with their electrons, they emit light, which is what gives the Orion Nebula its brilliant glow. The glow you see is mostly from hydrogen, but there are also traces of other gases, like helium, carbon, and oxygen, which contribute to the overall color palette. What's fascinating about the Orion Nebula is that it is essentially a stellar nursery. It is a region where new stars are constantly being born from collapsing clouds of gas and dust. This process starts when a dense region of the nebula becomes gravitationally unstable and begins to collapse under its own weight. As the gas and dust collapse, they heat up, eventually forming protostars. These protostars continue to accumulate material from their surroundings until they ignite nuclear fusion in their cores, officially becoming stars. At the heart of the Orion Nebula is a cluster of hot young stars known as the Trapezium Cluster. These stars are incredibly bright and emit a lot of ultraviolet radiation, which is responsible for ionizing the surrounding gas and creating the nebula's glow. The Trapezium Cluster consists of about 4 main stars, but there are actually hundreds of stars in this region that are still in the process of forming. These young stars are extremely energetic, with surface temperatures reaching tens of thousands of degrees Celsius. One of the most interesting features within the Orion Nebula is something called protoplanetary disks, or proplyds for short. These are disks of gas and dust that surround newly forming stars and are thought to be the building blocks of planetary systems. Essentially, what we are looking at in the Orion Nebula is the early stages of solar system formation. Some of these proplyds could be forming planets right now. Astronomers have discovered dozens of these proplyds in the Orion Nebula, and they are actively studying them to learn more about how planets form around young stars. The Orion Nebula is also full of turbulence and chaos. The intense radiation from the young stars is blowing away the surrounding gas, creating shock waves and ionization fronts. These shock waves can compress the gas in some regions, triggering the formation of even more stars. This makes the nebula a dynamic and evolving region where new stars are continuously forming, while older stars are dispersing the gas around them. One of the most incredible features of the Orion Nebula is its incredible variety of structures and textures. The nebula is made up of dense clouds, filaments, and cavities, all shaped by the forces at work within it. The dark regions you see in images of the Orion Nebula are areas where dense clouds of dust are blocking the light from the background stars. These dust clouds are important because they act as the raw material from which new stars and planets can form. Without these dense regions of gas and dust, star formation would not be possible. Other than the stars and protoplanetary disks, the Orion Nebula also contains a number of brown dwarfs. Brown dwarfs are sometimes referred to as failed stars because they don't have enough mass to ignite nuclear fusion in their cores like true stars do. Instead, they are somewhere between a planet and a star in terms of size and mass. Brown dwarfs emit very little light, but they can still be detected in infrared images of the Orion Nebula. These objects are fascinating because they challenge our understanding of star and planet formation. Are they more like stars that didn't quite make it, or are they supermassive planets? The answer is still up for debate, but the Orion Nebula is helping astronomers learn more about these mysterious objects. Another cool aspect of the Orion Nebula is that it is part of a much larger structure called the Orion Molecular Cloud Complex. This complex is a vast region of space, hundreds of light years across, that contains several nebulae, including the famous Horsehead Nebula and the Flame Nebula. The Orion Nebula is just one small piece of this enormous star-forming region. In fact, the entire constellation of Orion is filled with massive clouds of gas and dust that are home to star formation on a truly colossal scale. The Orion Nebula is also a powerful source of infrared radiation. This is because many of the stars in the nebula are still in the process of forming and are surrounded by thick clouds of gas and dust that block visible light. However, infrared light can pass through this material, which allows astronomers to peer into the heart of the nebula and see stars that would otherwise be hidden. Finally, let us mention that the Orion Nebula is constantly changing. The nebula we see today won't look the same in a few thousand years. The intense radiation from the young stars will eventually blow away the remaining gas, dispersing it into space and leaving behind a cluster of young stars. Over time, these stars will drift apart, and the Orion Nebula will fade into the background as the stars continue their journey through the galaxy. Now, it is not just the weird objects like nebulas or pulsars that are terrifying. Even planets like our Earth can still be equally unsettling. Believe it or not, some of the most frightening things fall into the same category as our home planet. For example, a planet made of diamonds. 55 𝗀𝗀𝗃. Now, before we take you for a virtual journey to this planet, we want you to imagine a place where the surface temperatures soar to unimaginable heights and the atmosphere is filled with toxic gases. And yes, it is also true that this planet is covered in diamonds. Welcome to 55 𝗀𝗀𝗃, one of the most extreme and bizarre exoplanets ever discovered. This planet challenges everything we think we know about the universe and what's possible in planetary systems. 55 𝗀𝗀𝗃 is a super-Earth, which means it is larger than Earth, but smaller than gas giants like Jupiter or Saturn. It orbits a star in the constellation Cancer, about 40 light-years away from Earth. That might sound far, but in astronomical terms, it is really now. What makes 55 𝗀𝗀𝗃 so fascinating and terrifying is not just its proximity to us, but its incredibly hostile environment and extreme conditions. First, let's talk about its orbit. 55 𝗀𝗀𝗃 is extremely close to its parent star, 55 𝗀𝗀𝗃. It is so close that it completes one full orbit in just 18 hours. That's right, what we experience as a year on Earth, this planet experiences in less than a single Earth day. Being so close to its star means that 55 𝗀𝗀𝗃 is subjected to intense heat. In fact, surface temperatures can reach up to 4,400 degrees Fahrenheit, or around 2,400 degrees Celsius. To put that into perspective, that's hot enough to melt most metals. The planet is tidally locked, meaning one side of the planet is always facing the star, cooking under extreme heat, while the other side is in perpetual darkness. The extreme conditions on 55 𝗀𝗀𝗃 have sparked a lot of speculation and research about its surface and atmosphere. Some scientists believe that the planet could be covered in oceans of lava. Given its proximity to its star and its intense temperatures, the surface could be a molten hellscape, constantly churning with volcanic activity. But the real shocking part is the planet's composition. Early studies suggest that 55 𝗀𝗀𝗃 might be rich in carbon, and under the intense pressure of the planet's interior, this carbon could have crystallized into diamonds. The idea that this planet could be a literal gem floating in space is both fascinating and mind-boggling. The possibility of a diamond-covered planet stems from the theory that 55 𝗀𝗀𝗃 formed in a part of the universe rich in carbon. If that's the case, the high temperatures and pressures beneath the surface could have turned the carbon into diamonds. This might have created a world with more riches than we can even imagine. While it has not been directly proven that the planet's surface is made of diamonds, the theory remains one of the most intriguing possibilities for our cosmos. But it is not just the surface that's extreme. 55 𝗀𝗀𝗃's atmosphere is just as hostile. Recent observations from Spitzer Space Telescope suggest that the planet's atmosphere is thick and composed of gases like hydrogen and helium. There is also evidence of volcanic activity on a massive scale. The intense heat from the star likely drives violent eruptions on the surface, spewing out gases into the atmosphere. Some studies even suggest that the atmosphere could contain cyanide, which is a highly toxic substance. If the heat does not get you on 55 𝗀𝗀𝗃, the poisonous atmosphere certainly will. One of the mysteries surrounding 55 𝗀𝗀𝗃 is its day-night temperature difference. You would expect the side facing the star to be blisteringly hot and the dark side to be much cooler. However, studies have shown that the night side of the planet is still relatively warm. This has led scientists to theorize that the atmosphere might be circulating heat around the planet, or that volcanic activity on the dark side is keeping it warm. Either way, 55 𝗀𝗀𝗃 does not follow the rules of what we think planets should be like. The discovery of 55 𝗀𝗀𝗃 has opened up new questions about planetary formation and composition. It is part of a 5-planet system orbiting 55 𝗠𝗀𝗃𝗃, and its unique properties have forced scientists to rethink their models of how planets form and evolve. For example, the idea of a carbon-rich planet challenges the assumption that rocky planets like Earth are mostly made of silicate-based materials. If 55 𝗠𝗁𝗃𝗃 is indeed a carbon planet, it means that planets can form with entirely different materials than what we are used to in our own solar system. What's even more surprising is that 55 𝗠𝗁𝗃𝗃 is not a gas giant like many other exoplanets found close to their stars. Its size, which is about twice the diameter of Earth, makes it a super-Earth, and its solid composition sets it apart from the more common gas-dominated planets we see in similar orbits around other stars. This raises questions about how super-Earths form and why some end up with extreme compositions like 55 𝗠𝗁𝗃𝗃s. While 55 𝗠𝗁𝗃 is far too hot and toxic to support life as we know it, studying it demonstrates just how different exoplanets can be from the planets in our solar system. It is a world of extremes: extreme heat, extreme pressure, extreme radiation, and yet it exists, orbiting its star at an incredible pace. This raises the possibility that there are many more exotic and strange worlds out there just waiting to be discovered. But some of those strange and terrifying objects have already been discovered, like 𝗠𝗁𝗃9b. Orbiting a star about 670 light-years away from Earth, in the constellation Cygnus, is the exoplanet 𝗠𝗁𝗃9b. This planet has earned the title of the hottest exoplanet ever discovered. In fact, it is so hot that temperatures on its surface rival those of some stars. If you think 55 𝗠𝗁𝗃 was extreme, 𝗠𝗁𝗃9b takes it to an entirely new level. That temperatures on its surface reaches a scorching 7,800 degrees Fahrenheit, or about 4,300 degrees Celsius. If you want to imagine that, that's hotter than some stars, including red dwarfs, which are the most common type of star in the universe. In fact, that temperatures on its surface is nearly twice as hot as the surface of our Sun. This makes it not only the hottest known exoplanet, but also one of the most inhospitable places we have ever found. The reason 𝗠𝗁𝗃9b is so hot is because of its close proximity to its host star, 𝗠𝗁𝗃9b. This star is much larger and hotter than our Sun, and 𝗠𝗁𝗃9b orbits it at an incredibly close distance, so close that it completes one full orbit in just 1.5 Earth days. That means a year on 𝗠𝗁𝗃9b lasts less than 2 days on Earth. The planet is also tidally locked, meaning the same side of the planet always faces the star. So, one side is constantly being blasted by intense radiation and heat, while the other side remains in permanent darkness. The extreme heat of 𝗠𝗁𝗃9b has some pretty dramatic consequences for the planet itself. First of all, it is likely that the planet's atmosphere is being stripped away by the intense radiation from its star. The ultraviolet light from 𝗠𝗁𝗃9b is so powerful that it is literally tearing apart the molecules in the planet's atmosphere. This process, called atmospheric escape, means that the planet is constantly losing mass. In fact, scientists estimate that 𝗠𝗁𝗃9b is losing tens of thousands of tons of material every second. Over time, this could significantly reduce the planet's mass, or even lead to the complete loss of its atmosphere. What's even more interesting is that the atmosphere of 𝗠𝗁𝗃9b is made up of atoms and molecules that are typically found in stars, not planets. Because of the extreme heat, the atmosphere is filled with hydrogen and helium gas, along with heavier elements like iron and titanium, which are usually seen in the atmospheres of stars. These metals are vaporized into gas form due to the intense temperatures. 𝗀𝗁𝗏𝗃 is basically a gas giant with an atmosphere that behaves more like a star than a planet. The presence of metals, like iron in the planet's atmosphere, also leads to some unusual weather patterns, such as metal clouds and possibly even metal rain. This planet's size is another amazing feature. It is classified as a gas giant, and it is about 2.8 times more massive than Jupiter, which is the largest planet in our solar system. However, despite its massive size, 𝗀𝗁𝗏𝗃 has a very low density. This is likely due to the extreme heat, which causes the planet's atmosphere to expand, making it more puffed up and less dense than you would expect for a planet of its mass. The planet's radius is about 1.8 times that of Jupiter, meaning it is not only more massive, but also physically larger. Another consequence of 𝗀𝗁𝗏𝗃's extreme environment is the likelihood that the planet is being distorted by its host star's gravity. Because 𝗀𝗁𝗏𝗃 is so close to its star, the gravitational forces acting on the planet are immense. These forces can stretch the planet, causing it to become more egg-shaped rather than spherical. This gravitational stretching, combined with the extreme heat, creates an incredibly dynamic and unstable environment on the planet. We are also fascinated by 𝗀𝗁𝗏𝗃 due to the fact that it orbits such a unique type of star. KELT9 is a Type A star, which means it is much hotter and more massive than our Sun. In fact, it is about twice as large and nearly twice as hot as the Sun. This type of star has a relatively short lifespan, meaning it burns through its nuclear fuel quickly and won't live nearly as long as smaller stars like our Sun. This raises an interesting question about the future 𝗀𝗁𝗏𝗃, because the star will likely evolve into a red giant and possibly engulf the planet before the star dies. The discovery of 𝗀𝗁𝗏𝗃 has been a huge milestone for astronomers studying exoplanets. It challenges our understanding of how planets form and evolve under extreme conditions. The planet's proximity to such a hot star and its ability to survive for now in such an inhospitable environment make it a fascinating case study for scientists. In fact, 𝗀𝗁𝗏𝗃 is one of the best examples of a hot Jupiter, which is a class of gas giants that orbit very close to their host stars. But while many hot Jupiters are extremely hot, none come close to the temperatures we see on 𝗀𝗁𝗏𝗃. One of the reasons astronomers are so interested in studying 𝗀𝗁𝗏𝗃 is because it offers a window into how planets might behave around different types of stars. Most exoplanets we have discovered orbit stars that are similar to or smaller than the Sun. But 𝗀𝗁𝗏𝗃 is much hotter and more massive, making it a unique opportunity to study how extreme stellar conditions affect planetary atmospheres, orbital dynamics, and even planetary survival. By studying 𝗀𝗁𝗏𝗃, scientists hope to learn more about the limits of planetary formation and the types of planets that can exist around stars of all sizes and temperatures. Next, we are going towards a planet that you can rather refer to as a circle of hell than its original name, 𝗀𝗚70b. We are talking about 𝗀𝗚70b. It is an exoplanet that truly breaks the mold when it comes to extreme planets. While we have covered planets that are incredibly hot or have bizarre atmospheric conditions, 𝗀𝗚70b is a literal hell. This planet is one of the hottest planets ever found. But what makes 𝗀𝗚70b even more fascinating is its past. It is a planet that has survived its star's death, which is a rarity in itself. Let's dig into what makes 𝗀𝗚70b such an intriguing and extreme exoplanet. First, let's talk about where it is. 𝗀𝗚70b is located about 5,500 light-years away from Earth in the constellation of Cygnus. That's not exactly next door, but still within reach for exoplanet hunters using the Kepler Space Telescope. The planet orbits a star called 𝗠ซี้𝘀𝗁𝗍𝗲𝗏, which used to be much like our Sun, but has since gone through dramatic changes. The star has already gone through its red giant phase, which is a stage in a star's life where it expands enormously and loses much of its mass. What's left now is a subdwarf B star, a compact and extremely hot remnant of its former self. 𝗠ซี้𝘀𝗁𝗍𝗏𝗏 orbits this subdwarf star at an insanely close distance, just 740,000 kilometers from the star, which is less than twice the distance from the Earth to the Moon. Because of this incredibly close orbit, 𝗠ซี้𝘀𝗁𝗍𝗏𝗏 completes a full orbit in just over 5 hours. This proximity means that 𝗠ซี้𝘀𝗁𝗍𝗏𝗏 is under constant bombardment from the intense heat and radiation coming from its host star. Speaking of heat, 𝗠ซี้𝘀𝗁𝗍𝗏𝗏 holds the title of one of the hottest exoplanets ever discovered. Temperatures on the planet can reach a mind-melting 12,000 degrees Fahrenheit or around 7,000 degrees Celsius. The extreme heat is due to its close orbit around the subdwarf star, which is still burning at tens of thousands of degrees. The most fascinating thing about 𝗠ซี้𝘀𝗁𝗍𝗏𝗏 is its history. The planet likely didn't start out in such a perilous orbit. In fact, it is believed that 𝗠ซี้𝘀𝗁𝗍𝗏𝗏 and its sibling planet, 𝗠ซี้𝘀𝗁𝗍𝗁𝗍𝗐, were once much farther from their star. They used to orbit at a safe distance before their host star went through its red giant phase. When a star like 𝗠ซี้𝗁𝗁𝗍𝗏 swells into a red giant, it expands to hundreds of times its original size, engulfing any planets in its path. Both 𝗠ซี้𝗁𝗍𝗏𝗏 and 𝗠ซี้𝗁𝗁𝗍𝗐 likely plunge deep into the outer layers of the expanding red giant star. During this phase, they were probably stripped of any atmospheres they had, leaving behind bare rocky cores. Surviving this close encounter with a dying star is extremely rare for planets. Most planets that enter a red giant's outer layers are completely obliterated, either consumed by the star or broken apart by the immense gravitational forces. But somehow, 𝗠ซี้𝗁𝗍𝗏𝗏 managed to survive this stellar near-death experience. The planet is now a scorched rocky remnant, orbiting dangerously close to its star's core. Another interesting fact about 𝗠ซี้𝗁𝗍𝗏𝗏 is its composition. Because it is so close to its star, the planet's surface has likely been stripped down to its metallic core. The outer layers of the planet were probably blasted away when it passed through the red giant's atmosphere. This means that what we are seeing today is likely a bare metallic remains of the planet's former self. The planet's density is incredibly high, suggesting it is composed mainly of heavy elements like iron and nickel. 𝗠ซี้𝗁𝗍𝗏𝗏 also has a sibling, 𝗠ซี้𝗁𝗁𝗍𝗐𝗏, which orbits even closer to the star, though closer is a relative term here since 𝗠ซี้𝗁𝗍𝗏𝗏 already skims the surface of its star. The two planets are so close to each other that they nearly touch during their orbits. In fact, the distance between 𝗠ซี้𝗁𝗍𝗏 and 𝗠ซี้𝗁𝗁𝗍𝗐𝗏 is just 240,000 kilometers, which is less than the distance from the Earth to the Moon. This close proximity means that the two planets exert significant gravitational forces on each other, possibly affecting their orbits in ways that we still don't fully understand. 𝗠ซี้𝗁𝗍𝗏𝗏's close orbit and high temperature raise some interesting questions about how long it can survive in its current state. Given its proximity to the subdwarf star and the intense radiation it is exposed to, the planet's future does not look so good. It is possible that over time, the planet could be pulled even closer to the star and eventually be torn apart by gravitational forces. Alternatively, the star's intense heat and radiation could continue to erode the planet's surface, slowly vaporizing what's left of it until it is gone entirely. Either way, 𝗂𝗏𝗴𝗲𝗍𝗍's days are likely numbered. This makes it a planet on the edge of destruction. After orbiting with the most terrifying exoplanets, let's take a plunge into cosmic voids, which are even more haunting. You see, cosmic voids are vast, empty regions in the universe, which cover hundreds of millions of light years, where galaxies, stars, and even dark matter are almost non-existent. These barren, horrifying spaces are like the dark gaps in the cosmic web, making up most of the universe's volume. It is so empty that, for millions of years, you would never come across a single galaxy, just a haunting, endless void. Let's start with the 𝗂𝗏𝗴𝗏𝗏 void. It is one of the largest known cosmic voids in the universe. This void was named after its discoverers, astronomers Ryan Keenan, Amy Barger, and Lennox Cowie. To give you a sense of its scale, this void covers about 2 billion light years, making it one of the most significant known voids in the cosmos. Now, the 𝗂𝗏𝗴𝗏𝗏 void stands out for a few reasons. First, it is incredibly large, much larger than most other voids we have found in the universe. Most voids range from about 30 to 300 million light years across, but the 𝗂𝗏𝗴𝗏𝗏 void blows that range out of the water, measuring roughly 2 billion light-years in diameter. It surrounds our local galactic group, meaning that the Milky Way, along with our neighboring galaxies like Andromeda and the Triangulum Galaxy, are situated near the edge of this enormous cosmic void. This position within the 𝗂𝗏𝗴𝗏𝗏 void has intrigued scientists because it could explain some oddities about our local universe. For example, our galaxy appears to be moving faster than expected relative to the cosmic microwave background, which is the leftover radiation from the Big Bang. Some scientists believe that the 𝗂𝗏𝗴𝗏𝗏 void's existence could influence this movement, as voids tend to have lower gravitational pull compared to denser regions of the universe, which might be pushing our galaxy outward. So, if this void is a place of emptiness, how did we even discover it? The 𝗂𝗏𝗴𝗏𝗏 void was first proposed in 2013 by the team of astronomers led by Ryan Keenan, Amy Barger, and Lennox Cowie. They were studying the large-scale structure of the universe and noticed that the region around the Milky Way appeared to be less dense in galaxies than surrounding areas. Using observations from various telescopes, they mapped out the distribution of galaxies around our local group and realized that our galaxy seemed to be situated near the edge of a massive cosmic void. This discovery has led to further studies as researchers attempt to understand more about the nature of the 𝗂𝗏𝗴𝗏𝗏 void and its potential effects on our local universe. The sheer size of the void has made it a topic of significant interest. So what if we used to live in the 𝗂𝗏𝗴𝗏𝗏 void? What would happen then? Living in a cosmic void sounds strange, but it does not have a direct effect on life on Earth. From our perspective, the universe still looks densely packed with galaxies and stars, especially when you look at regions outside the void. But being located near the edge of the 𝗂𝗏𝗴𝗏𝗏 void could have some subtle effects on the large-scale movement of galaxies, including our own Milky Way. Voids like the 𝗂𝗏𝗴𝗏𝗏 void are less dense than the surrounding universe, meaning that there is less gravitational pull within these regions. This can create what's known as void expansion, where galaxies within and around the voids appear to be moving away from each other faster than expected. In other words, the galaxies within the void seem to be expanding outward more rapidly than those in denser areas of the universe. This accelerated expansion could explain some anomalies in our measurements of the Hubble constant. The Hubble constant tells us how fast the universe is expanding. but scientists are getting different numbers depending on how they measure it. One method looks at the early universe, like the light left over from the Big Bang, while the other looks at galaxies closer to us. These two methods don't agree, and this disagreement is called the Hubble tension. The KBC void might help explain why. Since this void is such a large, empty area, it might be making the space around us expand faster than in other parts of the universe. Without as much matter around us, the gravitational pull is weaker, so galaxies in this region might seem to move away from each other faster. This faster local expansion could be affecting our measurements of the Hubble constant, especially when we look at nearby galaxies. It might make it seem like the universe is expanding quicker in our part of space compared to the universe as a whole. That could be one reason why the numbers don't match up when scientists use different methods to measure the expansion of the universe. Another similarly fascinating area near us is the 𝗏𝗏𝗏 void. The 𝗏𝗏𝗏 void is located about 700 million light-years away from Earth in the constellation 𝗏𝗏𝗏. It is often referred to as the Great Nothing because it is an enormous region of space that's almost completely empty. Measuring roughly 330 million light-years across, it is one of the most significant voids in the universe, and the emptiness it holds is terrifying. To put that size into perspective, the 𝗏𝗏𝗏 void is so vast that if the Milky Way were placed at the center of it, we would not see another galaxy for hundreds of millions of light-years in any direction. Even though space is already mind-bogglingly big, a void this size is extreme, even for the universe. So what's inside this enormous empty space? Not much. While most regions of the universe are filled with thousands of galaxies clustered together, the 𝗏𝗏𝗏 void has only about 60 galaxies inside it. For a region as big as the 𝗏𝗏𝗏 void, this is incredibly sparse. Normally, you would expect to find thousands of galaxies in such a large area, but the 𝗏𝗏𝗏 void is strangely empty. Scientists have studied this void for years, trying to understand how such a massive area of space could be so empty. But it remains one of the universe's biggest mysteries. The discovery of the 𝗏𝗏𝗏 void dates back to 1981, when a team of astronomers led by Robert Kirshner was mapping out the large-scale structure of the universe. When they came across the 𝗏𝗏𝗏 void, they were stunned by its size and emptiness. It was not just the absence of galaxies that made the void so interesting, but the sheer scale of it. At the time, it was the largest void ever found, and it continues to hold a special place in the study of cosmic structures. One of the things that still confuses us about this void is how it was formed. Scientists believe that cosmic voids form over time as galaxies and matter are pulled together by gravity, leaving behind large empty spaces. However, for a void as big as the 𝗏𝗏𝗏𝗏 void to exist, it would have had to grow much larger than most other voids we have observed. This suggests that the 𝗏𝗏𝗏𝗏 void is extremely old, likely forming early in the universe's history. The one thing that fascinates scientists the most about this void is the distribution of its galaxies. The galaxies that do exist within the void are not evenly spread out. Instead, they seem to be clustered near the edges, almost as if they are trying to avoid the center of the void. This creates a strange, hollow-like effect where the middle of the void is even emptier than the surrounding areas. Scientists are not entirely sure why this happens, but it is possible that the gravitational forces acting on the galaxies pulled them toward the edges as the void grew larger over time. While we were still trying to wrap our heads around the sheer emptiness of the 𝗏𝗏𝗏𝗏 void, we came across other terrifying phenomena that pushed the boundaries of what we thought we knew about the universe. Let's explore these cosmic horrors now. The first phenomenon we are going to look at is gamma ray bursts. These are terrifying because these are some of the most powerful and terrifying explosions in the universe. These bursts release more energy in a few seconds than the Sun will in its entire 10 billion year lifetime. But what exactly are they? Gamma-ray bursts are intense flashes of gamma radiation, which is the most energetic form of light. They come from incredibly violent cosmic events, like the collapse of massive stars or the merging of neutron stars. These bursts are short-lived, lasting from a fraction of a second to several minutes, but their impact is massive. There are two main types of gamma-ray bursts. 1. Long duration, and 2. Short duration. Long-duration gamma-ray bursts last more than 2 seconds, and these are typically associated with supernovae. Short-duration gamma-ray bursts last less than 2 seconds and are thought to occur when two neutron stars collide, or when a neutron star merges with a black hole. Both types of gamma-ray bursts create shockwaves that send gamma radiation blasting through the universe at nearly the speed of light. Now, the terrifying thing is that if a GRB were to occur too close to Earth, the gamma radiation could strip away our planet's atmosphere, exposing the surface to deadly cosmic rays and causing widespread extinction. Some scientists even think that a past GRB might have contributed to one of the mass extinctions on Earth. Fortunately, most of gamma-ray bursts occur billions of light-years away, far beyond the range that could directly affect us. But the immense power and unpredictability of these bursts make them one of the most fearsome forces in the universe. The danger comes from the narrow beams of radiation that gamma-ray bursts produce. These beams are so concentrated and focused that even from great distances, they can affect entire galaxies. If Earth were in the path of one of these beams, the consequences would be catastrophic. The gamma rays would instantly fry the upper layers of our atmosphere, causing chemical reactions that could destroy the protective ozone layer. Without the ozone layer, harmful ultraviolet radiation from the Sun would bombard the planet, making life on the surface almost impossible. The good news is that they are rare and distant, but their terrifying potential serves as a reminder that maybe, just maybe, one of these rays is what wiped out the dinosaurs. Who knows? Now, we are moving on to the next terrifying object found in our universe. We are pretty comfortable here on Earth, right? We know that we are safely bound by the Sun's gravity, which is keeping us in a steady orbit year after year. It is the same for most stars in the universe. They are locked into predictable orbits within their galaxies. But what if a star suddenly broke free? What if it got ejected from its galaxy entirely, speeding off into the vast emptiness of space? As wild as that sounds, it really happens. These are hypervelocity stars, stars that have been flung out of their galaxies at insane speeds, traveling through the universe completely untethered. Hypervelocity stars are rare, but when they do get kicked out, it is usually the result of a close encounter with something extremely powerful, like a supermassive black hole. When a star, or sometimes a pair of stars, gets too close to one of these black holes, the intense gravitational forces can rip them apart. One star might get captured by the black hole, while the other is sent rocketing away at an incredible speed, becoming a hypervelocity star. What makes these stars so fascinating is the high speed at which they travel. Hypervelocity stars can move at over 1 million miles per hour, fast enough to escape the gravitational pull of their entire galaxy. For comparison, our Sun orbits the center of the Milky Way at about 500,000 miles per hour, which is fast, but nowhere near the speed of these runaway stars. Since their discovery in 2005, only a few dozen hypervelocity stars have been identified. They are hard to spot because once they are launched, they leave their home galaxies behind and travel through the vast, empty regions between galaxies, far from other stars and celestial bodies. Most of the hypervelocity stars we know about were likely ejected from the center of the Milky Way, where a supermassive black hole lies and is constantly interacting with nearby stars. The idea that a star can be torn from its orbit and sent racing through the universe is a reminder of just how unpredictable the cosmos can be. Once a hypervelocity star is ejected, it is on a journey with no return. These stars are essentially forever on the move, traveling alone through space with no chance of falling back into the gravitational pull of another galaxy. While hypervelocity stars are fascinating with their wild speeds and dramatic ejections from galaxies, we have also found something similar, but not quite the same. We are talking about rogue planets. Unlike hypervelocity stars, which are blazing through space at incredible speeds, rogue planets don't have that same momentum or the ability to emit light, yet they are equally mysterious and terrifying in their own right. These planets are not tied to any star. They are adrift, wandering the galaxy completely on their own. Rogue planets are planets that have been ejected from their home solar systems and now float through space without orbiting a star. This typically happens when gravitational forces, either from a passing star or another massive object in their original system, kick them out of orbit. Once they are ejected, they become free-floating, no longer bound to a star's gravity. Unlike planets that remain comfortably in orbit around their suns, rogue planets drift in the cold, dark expanse of interstellar space. What makes rogue planets so elusive is their lack of a nearby star. Because they don't reflect starlight and don't emit any light of their own, they are extremely difficult to detect. The best way we have found them so far is through a process called gravitational microlensing. In this method, when a rogue planet passes in front of a distant star, its gravity bends the star's light, creating a brief brightening that can be observed from Earth. These events are rare, but they give us the best evidence we have of rogue planets. So, have we really found any rogue planet, or do we just have the idea of it? Well, yes, we have found them. One is OGLA 2016 BLG 1928, a planet discovered using gravitational microlensing. This planet is believed to be similar in size to Jupiter and is freely drifting through space, and it is untethered to any star. What makes this discovery particularly exciting is that it suggests rogue planets come in many sizes, from small Earth-like planets to massive gas giants like Jupiter. The number of rogue planets out there is another mind-blowing aspect. Scientists estimate that the Milky Way could be filled with billions of these wandering planets, potentially even more than there are stars. These planets, cut off from the heat and light of a star, would be incredibly cold, and any atmospheres they once had would likely be stripped away by the harsh conditions of interstellar space. These planets are like cosmic drifters, silent, invisible, and moving through space with no connection to a star. While we may not be able to see them easily, their presence challenges our understanding of planetary formation and the chaotic processes that occur in the universe. As much as we love to tell ourselves that the universe is fascinating and full of wonder, the truth is, it is far more terrifying than we like to admit. The deeper we explore, the more we uncover objects that defy all logic: stars being hurled out of galaxies, planets wandering through the dark void of space, and explosions powerful enough to wipe out entire systems. The universe is not just vast, it is chaotic, unpredictable, and downright dangerous. For all our curiosity, the cosmos reminds us just how fragile and small we really are in the grand scheme of things. This concludes our video. We hope you enjoyed the content and found it informative. If you did, please consider subscribing. It's free for you but helps support our channel. Thanks for watching, and we'll see you in the next video.